On to question 3. F of x is equal to x minus 8. G of x is x to the 4 minus 3, and h of x is f of g of x. So I'm asked first to find h of x. So h of x is equal to f of g of x, which is f of, and then x to the 4 minus 3. And f of x is just take the value you have and subtract 8 from it. So that would be x to the 4 minus 3, and then minus 8, which is x to the 4 minus 11. Part B, you're letting C be a point on the graph of h. That's that graph there. The tangent to the graph of h at C is parallel to the graph of f. You're asked to find the x-coordinate of C. So you know the tangent to the graph of h at C will be equal to the derivative, or have a gradient, sorry, of the derivative of h at that value of x. And it's parallel to the graph of f. F is a straight line of gradient 1, so you know it will equal 1. Or alternatively, you could just use f dash x, because the gradient of f of x is f dash x, which is just 1. So h dash x, I multiply by my power, subtract 1 from the power, 4x cubed. Minus 11 is the same as minus 11 times x to the power of 0, so that just becomes 0, is equal to 1, and therefore x cubed is equal to 1/4, and x is equal to 1 over the cube root of 4, and I'm just going to leave my answer as an exact value, as is my want. If I look at my mark scheme, for part A, I'm given a mark for any attempt to form a composite, even if I go in the wrong order, but you shouldn't be doing that, and then a mark for my correct final answer. Once again, no working necessary, N2. For part B, I do need to show some working. I'm recognising the gradient of the tangent is a derivative, h dash of x. I'm finding the correct derivative. I'm setting the correct gradient of f, either from reading it off my line, m is 1, or for differentiating x minus 8 to get 1. I then equate my derivative to 1 and find my value, which can be either exact or to 3SF. And that's 7 marks done.